everybody. This is Doug Vincent at Pactera Technology International. Just want to thank everyone for coming out to this webcast on big data. We have a very interesting topic today and a fantastic speaker with Kurt Luke, who is our Managing Director over Business Intelligence and Analytics. So I want to just take a few moments, welcome you, and give you a little bit of idea very quickly in the shameless commercial category of who it is that's speaking to you. First of all, Kurt joins us after a long career in business intelligence and analytics, and that, of course, is one of the specialties that Pactera provides our clients. A little bit on Pactera. We're probably one of the biggest companies you've never heard of, and and we went through a recent merger that allows us to, or gave us an opportunity to change our name, and in the process adopted a name that I'm sure you haven't heard, but at the same time, we're a fairly large company. So Pactera is based in Beijing, China. We're the largest IT services company out of China, with our North American headquarters out of Charlotte, North Carolina. We've about 35 offices around the world, 24,000 employees, publicly held on the NASDAQ under the symbol PACT. Most of our clients are Fortune 500 companies, and so a lot of what we're talking about are the type of solutions that are being adopted by leaders in the industry and financial services and retail and consumer packaged goods, and in many respects, high-tech companies like Microsoft, HP, organizations that are really leading the technology wave. So I'm going to turn this over to Kurt in a moment, but just to give a little bit of an insight on us, our organization basically provides big data solutions, analytics solutions, mobility, cloud, and so forth, innovative technologies out of U.S. offices, European offices, and we have 21 offshore offices in Tier 1 and Tier 2 cities out of China. So with that said, I'm going to turn it over to Kurt, and I hope you enjoy the webcast.
Good afternoon and good morning on the West Coast. I appreciate everybody's attendance and sincerely hope that you gather some great information on this presentation today. It's a pretty exciting topic, at least to me, and I'll assume for you as well if you're on the call. As promised, we've got our 10 steps, 5 critical mistakes, 2 success stories, but I wanted to start with some quick definitions, drivers, and key predictions around big data. The presentation, just to set kind of expectations, was built as a primer on big data, and we'll be having several probably follow-up presentations in the coming weeks and months that dive deeper into industry, industry, for example, like financial services and retail, and particular vendor solutions, for example, answering questions like what's Oracle's big data solution. All right, let's go ahead and get started. Okay, so I would be shot if I didn't start with the 3 V's. The definition, if you're going to do a primer on big data, you've got to start with the 3 V's. The definition of big data has been really a work in progress over the past few years, but the established definition at this point has really been around what's called the 3 V's. And the 3 V's are volume, velocity, and variety. And so what do they mean? Well, volume is probably the most mentioned. That's really just talking about the sheer volume of data that has been, like I said, one of the biggest drivers for the need for big data projects. Velocity, well, as the saying goes, speed kills. And really, things like social media put the bullet in most traditional attempts in a lot of industries to handle it via the traditional relational data warehouse, enterprise data warehouse approach. Industries such as energy have really been overwhelmed by things like smart grid initiatives. And really, each industry has its own area that has sort of stopped the traditional approach. All right, the last V, or the third V, is what's called variety. And if it was really just traditional data that we were talking about in this conversation, then even the first two V's really wouldn't be kind of the bullet in the traditional approach. But the fact is that we've got a lot of different types of data. Traditional databases like Oracle DB2, Microsoft SQL have handled that data. We've been able to store audio and video and things like that for a number of years, but actually being able to do something with it is a different topic, and that's where the three V's and big data come into play. What's the fourth V? I mentioned that there's actually sort of discussions around a fourth V, and I'll just leave that as value. There's a number of other things, but for the most part, the three V's is the established definition. All right, let's go to the next page. Okay, so I wanted to talk for a moment about kind of the drivers for big data. And the first one is something called the growth of dark data, and this is not a Star Wars term. What dark data really refers to is data that we've been storing for a long time. Old invoices, customer satisfaction, a lot of textual, audio things and types of data, but we really never did anything with them. In many cases, we had to store them for regulation purposes, especially within the medical industry, but we didn't do anything with them. So this is where the term dark data comes into place. And it's really the drive from the business perspective of, you know what, there's a lot of insight within this, quote, dark data. So that's the first driver. All right, the second driver is the increasing need to process data, and then I put in parentheses, efficiently. Enterprise organizations have been slowly adding data through many, many development projects, but they're doing it at too slow of a pace. And business wants to take all the data within the enterprise and be able to put it together and to get some business solutions. I was recently at a bank, one of the largest banks, and the CTO was basically conveying to me that we just flat out can't continue adding more Teradata. Just the sheer cost of adding one more Teradata box was becoming too expensive. If you looked at this on a graph and projected it out, it would just be exponentially expensive. So a new solution was required, and that's another driver for big data. All right, last driver is really falls within that 3V, the explosion of variety. If the data was always a nice set of columns of text and numbers, well, we'd all be in perfect shape, frankly. We'd figure out ways to process things more quickly within the relational databases in memory and that sort of thing. XML a few years ago was meant to help to take semi-unstructured data and put it into a nice relational format. But unfortunately, just the explosion of the variety of data is taking the ball so far off the track that really a new solution was required. Again, social media is a huge case in point. It's completely unstructured, but we all know there's actually a lot of valuable data in the social media. And what about audio and video? All right, let's go to the next one. All right, so go ahead and push those all through. So the big data predictions, this is really coming from our friends at Gartner. And I'm not going to read through each one of these, but I put them up here because I really felt like they were spot on. They're correct, and they give some context within a primer type presentation. I was recently at a TDWI conference on big data, and the group was reminded that there have been a number of terms and products that in the beginning were used, and now this is kind of big data. They were used in front of every product, for example, web-enabled. And I think that that's the assumption for this as well, is that over the years, we'll stop talking about big data. That will just be part of business intelligence. So, all right. And the last point I wanted to drive home here, hopefully when you're reading through these, is that the amount of jobs that will go unfulfilled in this big data arena is just staggering. From a personal perspective, if you have college kids, this is probably a good area to direct them. But I think it really takes a very science-oriented mind to really engage this profession. So if your son wants to go into professional football, he's probably not going to like big data. Anyway, let's go to the next slide. Okay, so part of when I first started looking at big data and started getting engaged in it, there were so many terms in this that I was very, very confused as to where to start. So we're going to start with the basics here. So for a big data solution, you really need two things, Hadoop and MapReduce. So Hadoop is used generically to discuss the big data platform, but more specifically, Hadoop is a file system. I've had to train myself to stop calling it a database. It's really not a database. It really is simply a file system, and it's the starting block for any big data solution. MapReduce, well, I'll read according to Wiki, is really a programming model for processing large data sets. It's the name of the implementation and the model that was created actually by Google. Now, there's a lot of varieties of that model now, but MapReduce is typically used to do distributed computing on clusters of computers. And let's go ahead to the 9 steps for creating a BI, or I should say a big data project. All right, so I'm going to move through these because we're going to actually go through most of them one at a time. All right, those are the 9 steps. All right, so step 1, what is your problem? I loved this graphic. I found this graphic that basically talks about the different industries and the likelihood of needing big data. So the way to read this is basically if you had red all the way down, then you're in a high likelihood of being able to leverage big data. Most IT departments are feeling fairly overwhelmed with the amount of data and the amount of pressure from the business to combine data to provide business insight. These types of projects can be a pretty exciting opportunity for IT and business to work together to come up with some very, very insightful project. So again, I just felt like this was very useful to look at to kind of see the different areas and the different reasons for why you might want to start a big data project. But the bottom line is, we've got to figure out what is the business problem. And so the second step is really to figure out what's the business case. So it should be fairly obvious, but reading a big data article in CIO or CFO magazines does not mean that you need to have a big data solution. You need to figure out for your specific company what is the business case business problem that you're really trying to accomplish. Big data business problems typically have the following characteristics: combining multiple types of data, that's the variety; large volume, that's the V, or the V of volume; and I'll add this realistic ability to create value from the project, and that's really that last or the fourth V. We need to engage projects where there's a realistic opportunity to provide value back to the business, or else you're going to get done with the project and business is basically going to say, who cares? So a few examples that I wanted to make this as real as possible within many of the industries. So financial services industry, just to list out a few problems that people are using big data solutions for: customer service, context-aware sales and service, a lot within segmentation, and that goes really across almost every industry that we engage with. I just got off the phone with a large energy company in the Northeast, and one of the things that we're talking about them is with customer segmentation. Big data really allows for us to do that so much better than we were able to before with just traditional, basically adding up rows and columns of data. All right. In many cases, despite the significant size of your company, you don't have the experience within the four walls, and don't feel bad. Most organizations don't. The main item that I worry about when people say they want to start a big data project is around the resource. And I'll just cut to the chase and say that most organizations do not have this role called a data scientist. So let's talk about the data scientist. You can see the rest of the roles up there. And I think most organizations have good project managers, good people who understand data, and probably people who have some solid Java programming, which is going to be a requirement for big data projects because a lot of it's open source Java type technologies. So I'm not so worried about that, but I would, as a cautionary note, say that if you don't have a big data or if you don't have data scientist type of resources, then you need to look into them and to figure out who they are, what they do, and why you need them. But so to make a big data project on any analytics project succeed, you need a lot of different skills. I think that the combination of functional and technical skills, most people, when they think of a data scientist, they really think of the technical side, and their minds immediately go to the analytics portion, which is important, but really I don't think it's the whole part of the story. So let's talk about the two different sides. So analytics, it's the thing around statistics, operations research, computer science, machine learning. These are all important things in regards to a data scientist. But the second functional area is around design, which is basically being able to create an interface to the data so people will find it usable. And, when we talk about these two different areas, it's likely that you're not going to find one person who has that. It's a lot of times somebody who's very analytical doesn't necessarily have that design. My prediction is that we will form great teams over the this 2013 and beyond of people that can work together to come up with that full set of a person. And that'll take time. That'll take time of trying a few things and failing, but I'd suggest that you begin forming that sort of department or project team and begin having people try to work together to fulfill this position. All right. So let's go to the next slide. Okay, so I love this this picture here. It really it basically shows the insanity of the marketplace within big data. There are so many different players that are involved with it, and a lot of them are really coming up and going down. So it's a market that is absolutely quite a bit in flux. All right, so let's look at something that looks a little more reasonable. Hopefully you can find this a little more readable to look at. My recommendations are twofold when you start to look at building out the technical architecture. The first is to determine, as we stated earlier, what's the problem you're attempting to solve. If the problem is so complex that it requires a very specific solution, then you may want to purchase something on this top section that is a product that really answers very specific industry problems. The second of the kind of twofold of looking at is, if possible, I'd recommend that you look at more of a big vendor, such as like IBM or Oracle, Cloudera, for your base platform of a big data solution. And I say this because the market's just changing so much that my recommendation is not to, or at least to go into it with caution if you're going to take a smaller niche player, because you don't know if they're going to be there. The market it's just in a dramatic flux, which happens in any kind of these sort of big hype cycles. All right. So again, I put this presentation together as a primer, and I really tried to put myself in the perspective of, first looking at big data and the projects that are around that, and I wanted to answer the questions that I had when I first started. And when I'm a fairly technical guy, and when I get involved with these, I wanted to understand, well, what does this really mean under the covers? I've heard all the hype, but what does this mean from a technical architecture? So this is what I would typically see. We pulled this from a project that we've done recently of a typical enterprise data warehouse. It's got the 3 layers. Start at the bottom with your source systems, then you've got the middle layer, your data layer, and then your analytic layer, and your presentation layer. What I wanted to understand is what was replaced from a big data perspective, and what are the sum of the products. So that's what I've really tried to do here on this. Sorry, the visual's not the best, but I think you get the idea. So remember Hadoop that we talked about is the distributed file system that facilitates the data among the really thousands of nodes. HBase, which you can see kind of across the top, is in this particular implementation it's a sub-project within the open source community, and it provides really real-time read and write access to your big data. And the primary objective of the Apache HBase is really hosting very large tables on the top of really clusters of commodity hardware. And I didn't mention it earlier, but really a lot of the cost saving from these projects is, instead of using Teradata, and not that there's nothing wrong with Teradata, but instead of using these high-end hardware solutions, it's really just leveraging literally hundreds of commodity type servers. Another term here is Hive. So Apache Hive is a data warehouse system for open source Hadoop project, and Hive features, for those of you who love SQL, you'll feel at home here, because Hive features basically a SQL-like, I said SQL-like, it's not all full ANSI SQL, but SQL-like language that facilitates data analysis and summarization of large data sets that are stored in Hadoop. So this is basically a way to get the data out. In the analytics layer, we have something called Mahat, and it's basically what it allows you to do is it's really the recommendation layer, or I should say the predictive analytics layer. So I've listed kind of 4 things here that you can get from that layer of the product. And so it has things like recommendation mining, which takes user behaviors and then tries to find items that users might like. It does clustering, like text documents, and groups them into groups of related documents. Classification, it learns from existing categorized documents what documents of a specific category look like, and is able to assign unlabeled documents to, hopefully, the correct category. The last one I'll sort of mention here is it has frequent item site mining, which takes a set of item groups, like terms in a query session, shopping cart content, and identifies which individual items usually appear together. So again, very predictive analytics type of software at that layer. So think of this portion as like SaaS. Okay, So what are the mistakes that we're seeing within the big data projects that have started? And honestly, other than companies like Google and Facebook, LinkedIn, they've been doing these types of projects for many, many years, and they've learned a lot of different things. So some of these mistakes are from some information from what they've stated that they've made mistakes on, and then some are from projects that we've seen over the past year or so. And I'll start with the first one, and this is the lack of expertise. And I'm not actually referring to Hadoop or Java expertise, but it's the case, because if that was the case, most of the projects really would never get off the ground. If you don't have those core Java, Hadoop resources, then you're not going to get anywhere. But worse than that is having that expertise, but not having the expertise of kind of critical thinking individuals like we talked about with the data scientists, because what you'll end up doing is developing a project that doesn't really give you any value. The second critical mistake is big data projects without a problem. We are certainly in a hype cycle around big data, and this is a natural problem with any technology such as this. More than likely, your company does have some business problems that can be assisted with big data solutions, but the alignment between savvy business users and technology-enabled IT departments is still definitely in the works. The third is a lack of technology alignment, and I'll just refer back to all of the vendors that are out there and just give you some caution to make sure that don't launch into a very point solution and purchase a very point big data solution only to turn around and accomplish that one goal and find out that that's not really going to help you for the next set of things that you're trying to look at. All right, so the fourth one, and this really flows directly into my previous one, and that is develop a long-term roadmap. If you're going to start a big data project, that means you're going to probably be purchasing and hiring resources and expending a lot of money. But so I just would recommend that you step back and look at the organization much like you would look at it from a BI strategy, but now look at it from a big data strategy perspective. Identify the different departments and what the projects that could be formed and what types of business problems could be solved through big data. From a Pactera perspective, we have a sort of a quick engagement that basically allows us to come in, work with your organization, and skim across the business to identify areas that are pretty common, and then to dig down in those to figure out, could you actually get some kind of value out of that? The fourth piece is a lack of critical evaluation. I feel like this is probably not so much a big data piece, but just something that I see from the market, and it's most missing in a lot of IT projects. At the end of the project, we really need to be honest with ourselves and look at the expected business goals and answer if we actually achieved those. All right, let's go to the next page. Okay, so I wanted to present two case studies, and the first project, we've been pretty engaged with it, so I'll call it the Acme Online Travel, so that we keep the innocent. So Pactera has had a relationship with this company for a long time. It's one of the largest travel companies in the world, and as you can imagine, there's quite a bit of data involved with any of these sort of online type of clients. And we understand the business very, very well simply because we've been doing business with them and really are a strategic partner with them. But we also understand the weakness of we understood the weakness of the BI solution because we had been pretty instrumental in building it. And the volumes of data were really just becoming so high, the cost was becoming too much to incur on a continued basis. Data sources for the client would be probably your usual suspects. traditional ERP systems, clickstream data, social media. Really, petabytes were the norm within this client. So part of the main driver for the project, but not the only thing, but part of the main driver was to reduce the cost per terabyte from what was running at one point within around $10,000 USD for each terabyte. So a few years ago, we suggested to the client that we begin looking at big data solutions if we were going to continue to really be competitive in this industry. We started with a few POCs, sort of dabbled in it, and then we began building it into the current BI system. At first, really replacing just portions of the BI solution. And I'll just cut to the end and say that there's still a very much a traditional BI portion, very relational, Oracle-related data warehouse, but now there's other portions of a lot of the data is only in the big data section. The other thing I'd say is that we're now sort of seeing the beginning of the kind of the, quote, natural death of some portions of the traditional BI system because business users are simply going to the big data portion of the system simply because a lot of the data that they need is there. For us, the most interesting kind of hard-hitting is the predictive analytic functions that are now being built on top of the base Hadoop file system. We talked about some of those products earlier. One of the most recent changes, and this is pretty exciting, not just for this client, but across the industry within big data, is moving towards near real time with a newer product called Impala. Impala is just being released to the general public, but we've been working with Impala for the past few months and beginning to put that into the system, really to provide, like I said, that real-time capability. All right, so this slide right here, I wanted to share this and talk about Impala for a moment because I think most organizations are going to be using this because it really addresses one of the issues within big data solutions. The graph shows our own testing at this client with petabytes of data. And as you can see, the performance is quite stark between Hive and Impala. So remember, Hive is kind of the ability to use SQL. What's interesting also about this, and the statistics down at the bottom, is that despite the success with big data, that the client, a lot of use is basically of big data is to pull the data and then put it into relational database systems. And a lot of that's just because people are more comfortable. I think that will change over time. And please keep in mind when it says faster on the third line, it's really referring to much smaller sets of data that were placed into the RDBMS. In conclusion, the solution that we built is faster. It's producing more intelligent insights for the client that, to be blunt, the client had to do it to stay competitive. In certain industries, everybody's engaging in this, and this is definitely one of those. So they needed that to produce the intelligent insights that are built into the system. And the cost now has been reduced from 10,000 USD to now 2,000 per terabyte. So that's a significant cost saving. All right, let's go on to our second one, our second case study. All right, so I'm going to leave this picture up here, and I'll just talk to it. There's really not going to be any words on this. The final case study that I wanted to really present was around a retail case study. And the picture that you're seeing is the goal of most major retailers. The goal is to drive a marketing and eventual sales down so personalized that it feels like they knew the customer or you on a one-on-one basis. But we need to stay on the right side of the creep factor, and that is when the customer feels violated. Violated. So this was the case with this client. Our client had a mix of the following types of data. They had store, point of sales, web, clickstream, social media. Of course, they had several financial systems, a bunch of spreadsheets that actually were very relevant, customer satisfaction data and other kind of unstructured data. They also had a lot of call center data. So combining all this, it was getting into the data warehouse, the enterprise data warehouse, but it wasn't all in there, and some of the unstructured was really, frankly, not in there. And so what we did was basically to combine all this using a big data solution. The project started with a POC, and I think you're going to see this on almost every single big data project because it's so new, and that's fine. It started with a POC, but it's now reached into several different departments. Examples of business problems that we have built these solutions around and are helping customers to accomplish is around customer buying behavior, price optimization, as in changing prices on the web based on behavior, and space planning. All of the projects were accomplished with really a theory, a model, and then a lot of testing. And once the kind of predictive models had been built, tested and tested and tested, but then and only then were they really put into the operational system. So this is definitely a case of kind of embedding big data into your existing traditional data. What I walked, or I should just say at a summary level, what I've walked away from many of these big data projects is big data and predictive analytics are extremely close together. And a lot of these are really very psychology related when it finally gets closer and closer to the customer. And this is definitely the case within the retail area. All right, what I wanted to kind of end on was, and I don't have the picture up here, but if you haven't read this article, it's Google this. Basically, it's how Target figured out a teen girl was pregnant before her father did. And so I'll just end on some level of cautionary note that with all of this technology, we have to be careful that we don't cross the line. Big data enables us to combine information that we've never been able to combine before and come up with some really interesting insights. If the real quick version of the Target story was basically that Target put together a group of data scientists, did some fantastic predictive analytics, and put it into place, and basically began targeting and sending out advertisements to people as they detected that maybe they were pregnant. And they did it so well that they actually sent it out to a teen girl whose father got the advertisements, went to Target and said, "What are you doing?" He was not happy, as I would be as a father as well. But it turned out that the Target was correct. But it just goes to show that we need to be careful with the technology that we have. That's the really short version, so feel free to Google it. All right. Okay, so I wanted to end on the kind of the focus areas, and I end on this because I think that really a lot of them, they all kind of go together. So voice of the customer, predictive analytics, big data, and finally on the front end, visual performance management type tools. This, to me, is sort of the next thing for what I would consider business intelligence for the last, 15 years as being relatively stagnant. But with big data, with agile, with textual analytics, these are the focus areas for us, and I would suggest that all enterprise clients should be looking at things like this. All right, I think we've gotten a few questions that have come in. So let me turn it over to Natalie. If you could just read off the questions that are coming in on the presentation.
Sure. Thanks, Kurt. The first question that has come in is, what is Hadoop's role in data warehouse?
Well, as I said earlier, Hadoop, and really let's just say big data, it's not a replacement, although maybe in 5 years some of this technology replaces our traditional data warehouses, but for now it's really just an addition to it. So I'll leave that at that. Next question.
Thanks, Kurt. What's the big data difference and request from data processing before?
Besides the 3 V's, big data processors require more efficient data processing on semi-structured and non-structured data. So as I said, this is a factor of if it was just columnar data, in other words, spreadsheet-like data, then we wouldn't really need big data solutions. But because of the structured and semi-structured, we definitely need that.
Another question that has come in is Hadoop, like open source, really complex to use by enterprises?
Well, I would put it this way: it's gotten a lot easier. The open source solution around Hadoop has a lot of people who are now engaging in it. So it's much easier to find solutions. It's much easier to find resources as far as Java programmers and resources that have experience within that. Again, I'd say that the complexity is not necessarily in the technology. It's probably more in the data scientist side.
Okay, another question that has come through: what challenge of Hadoop in big data process?
All right. Well, I think that, and this is getting better, but the traditional challenge around Hadoop and processing large volumes of data, I assume that was the question, is the bottleneck at the low efficiency in batch processing. So real-time streaming of data has been something that's been tougher, but there's beginning to become more and more components that make that a reality.
Okay, thanks, Kurt. We're going to go over one more question here. It's also regarding Hadoop. Will Hadoop totally replace RDBMS?
Well, so as we said before, it's not going to replace it, at least not for the short term. In the short term, no. Its advantage really is in bulk data processing. For long term, NoSQL databases on top of Hadoop will have opportunities to change the world of relational databases. What I suspect actually happens is that what we really end up seeing is traditional relational database systems beginning to ingest more and more features of big data solutions, such that there aren't these stark differences between the two. They're really all combined into one.
Okay, thanks. That's all we have time for the questions right now. We will be following up with all of you that attended our webinar with Kurt's contact information. We appreciate you attending the webinar today, and we hope you have a great day. Thank you so much.